All right, let's kick things off with a question. You see this line of code right here? I mean, we write stuff like this all the time, right? But have you ever stopped to wonder, how does the computer actually get this? How does it go from these familiar words and symbols to a real calculation? It feels like magic, but I promise you it's a super cool process.
Well, you can think of it like this. Every single line of code you write goes on a little journey. A journey from being just, human readable text into an actual machine executable action. So today, we're going to follow that journey from start to finish and break down exactly how it all works.
In this journey, it really has three main stops. First up, we've got something called lexical analysis, which is basically just a fancy way of saying we chop the code up into meaningful pieces. Then a parser comes in to check if all those pieces form a grammatically correct sentence. And finally, the interpreter steps in and actually runs the instructions. So chopping, checking, and running. Simple enough, right? Let's dive into that first step. Okay, so our first stop is the lexer. I like to call it the word chopper, because honestly, that's pretty much what it does. Its whole job is to take our raw code and just chop it up into understandable chunks. It's all about prepping it for what comes next. So let's look at our line of code again. To you and me, this is a perfectly clear instruction. But to the computer, at first glance, it's just a jumble of characters. It doesn't mean anything yet. The lexer, that's the very first step in making sense of it all.
So this lexer, which you'll also hear called a tokenizer, scans our raw string of code. Its job is to break everything down into these meaningful little units called tokens. And it's smart, too. It gets rid of all the stuff that doesn't matter for execution, like extra white space or comments you've written. Think of it as the first round of cleaning and organizing.
Well, what is a token, really? The easiest way to think about it is as a labeled piece of your code. It's the smallest possible unit that actually has some meaning. So each token gets a type, like, hey, this is a keyword, and it has a value, like the word let itself. This whole process turns a dumb string of text into something structured and categorized. And here's what it looks like in action. See that? Our one line of code has been transformed into this nice, orderly stream of tokens. The lexer was smart enough to see let and say, that's a keyword. It saw results and called it an identifier, which, by the way, is just a fancy word for a name you give something. The equal sign, that's an operator, and so on. By turning our code into this structured list, we've set the stage perfectly for the next step, the parser, to come in and check the grammar.
All right, so now we have our stream of tokens. But just because you have a bunch of words doesn't mean you have a sentence, right? That's where our second stop comes in, the parser. I call this one the grammar inspector. The parser is basically a really strict grammar teacher for your code. It takes that whole list of tokens from the lexer and checks if they're arranged according to the programming language's rules. Just like the cat sat on the mat is a valid sentence in English, let result equals 10 is a valid statement in code. The order of things is absolutely critical. And oh boy, this is a feeling we've all had, right? Ever forgotten a semicolon or missed a closing bracket? And suddenly your whole program just refuses to run? Yep, you've met the parser. It's the one that screams syntax error at you when your code breaks the grammar rules. Now, if your grammar is correct, the parser does something really clever. It doesn't just say, okay, looks good, and move on. No, it builds a logical map of your code. You can kind of picture it like a family tree for your instruction, showing exactly how everything is connected. This map has a technical name. It's called an abstract syntax tree, or AST for short, and it's the perfect blueprint for actually running the code. Okay, we have our blueprint, our AST, from the parser. Now it's time for the grand finale, the part where stuff actually happens. Let's talk about step 3, the interpreter, aka the executor. The interpreter's job is pretty straightforward, actually. It just takes that blueprint, the AST, and walks through it, bringing it to life. It follows the branches of that tree, carrying out every instruction it finds along the way. It sees the node that says add 10 and 5, and boom, it does the math. Then it sees the part that says assign that value to result, and it stores it in memory. It's the one that does the work. And this right here is the key thing to know about an interpreter. It executes the instructions directly from the parser's output. It doesn't have to go through this whole extra step of translating the entire program into machine code first. It's immediate. It's an on-the-fly execution, which makes it really, really good for certain kinds of tasks. So this whole 3-step dance, lexer, parser, interpreter, is happening all the time behind the scenes. But what if you don't want to write a whole file every time? What if you just want to test a quick idea, one line at a time? Is there a way to do that? You bet there is. There's a perfect tool for exactly the situation. It's called the REPL, and the best way to think of it is like an interactive workbench for your code. It's basically a way for you to have a direct, line-by-line conversation with the language's interpreter. REPL is actually an acronym. It stands for Read, Eval, Print, Loop, and that name perfectly describes what it does. It's this interactive environment where you type something in, it reads your code, evaluates it with the interpreter, prints the result right back to you, and then it just loops back and waits for your next command. And here's that loop in action. It reads your input. It evaluates it using that entire lexer, parser, interpreter pipeline we've been talking about. It prints the result, and then it loops right back around, ready for more. It is an absolutely fantastic tool for just playing around, experimenting, and learning a language. And you know what? You've almost definitely used one of these before. That JavaScript console you open up in your web browser, that's a REPL. The interactive shell you get when you just type Python in your terminal, also a REPL. They're super common and just incredibly useful in so many modern languages. So there you have it. That's the journey. We started with a simple line of text, watched it get chopped up into a stream of tokens, then organized into a proper grammatical structure, and finally executed to get a result. It's this really logical, kind of elegant process that takes our human ideas and translates them into the computer's actions. Okay, so we've totally unpacked how an interpreter works, right? It runs our code on the fly, piece by piece. But here's the thing. That's only half the story. There's this whole other approach called compiling, and it's a completely different way of thinking. So that leaves us with a pretty big question. What exactly does a compiler do differently, and why do so many of the world's fastest programs depend on it? Well, that's a journey for another day.